I'd like to talk to you about a set of VCV modules I worked on. So this is a set of interconnected modules. The idea here is that it is made to create complex tracks directly on VCV. So it is based on patterns that you arrange on a timeline, and then you can edit the pattern with a tracker view. So as you can see, this module, which is so the tracker, it is the main module of the set, has no input or output. The idea is that it will output all the track information with the other module of the set. So you have the T synths and the T drums, which will output pitch information, gate, velocity, panning, and eventually, and then you can also have modulations. And for the drum, which is working the same way, but without the pitch, because the pitch is used to divide, to be divided into 12 channels. You have also other basic modules. So you have T-phase and T-clock, which are respectively synced LFO with different wave shape, and T-clock, so which is a clock generator with a time multiplication or division. And then you have the T-quant, which allows you to change to quantize external pitch information to fit your track tuning, because you can change the whole tuning of your track within the tracker module. Finally, we have T-state, which does not do a lot of stuff, but allows you to have a kind of visual representation of your track. So here, if I play, you can see some dots. So they represent all the instruments playing. And then you have some small basic outputs. You have a playing gate, play and stop triggers, and so on. So this is the tracker module. So as I said, it is based on patterns. So you have this for view. You have the pattern view, which allows you to edit the pattern and create synths. So the synths are common to all the patterns. And then you have the timeline view, which allows you to create patterns and arrange them in your timeline. You have the matrix view, which is not working yet. And the tuning view, which is a work in progress, but allows you to have a representation of the tuning you're using here. Okay, so let's begin with the timeline view. So here, as you can see, I have three patterns. So pattern lead, pattern bass, and pattern drums. There are I can put, by selecting one pattern, I can put the pattern to the timeline just by clicking on it and then clicking on the timeline. I can move it, I can extend or shrink it. Here you have small dotted lines which allows you to see how the pattern repetition is working. You can then mute or delete the pattern instance. To create a pattern, you simply have to click on the plus here, and then you can change the pattern name. So let's call it pattern example. You can change its color. Let's go with light blue, and then you can change the pattern length and time signature here. But to do so, you will have to click on the update pattern so that the pattern length is updated. So let's see how a pattern works. So I will go to the pattern lead for now. So as you might see, I just have to go to the pattern. You can simply do so click on the pattern and go to the pattern view, or double click on the pattern. From here, you can see all the synths. So a synth in the tracker should be connected to a T-synth in your patch. So here I have three synths. So lead, as you can see, when I select one of the when I select synths, the T-synth and the T-drum display is highlighted depending on which one is selected. So here, this T-synth is connected to the lead synth. I can change it. Here it's the same. So I can simply, for an example, create another synth. So example, let's red color. It's okay, and then you have so you have information about the polyphony channels for the synths. By default, it's 1, but you can go up to 16, and then you have the synth gate mode. So by default, it is set to gate, which means that the gate will be always on unless you write not stop information. You also have the trigger mode, which will send only triggers to the patch. And you also have the drum mode, which will send triggers as well, but will split the notes between the different channels. So let's delete this example synth. So here, the tracker view is quite easy to understand. So you have I can right click on the screen and edit the pattern length here and the time signature, the number of note columns I want. So note columns are the columns to write notes, and CV columns are the columns to write modulations. So a note column is is made of a pitch, an octave. Then you have the velocity from 0 to 99, the panning from 0 to 99 too, but 50 between being the center. Then you have in yellow you have the synth ID. So here I have 00 because I'm using the lead synth. But if I go to the pattern base, you can see that here I'm using 01, which is the base synth. Okay, and then you have the delay, which is the time before the notes should start. 0 being immediately, and 99 being almost at the beginning of the next line. And then you have the glide, which is empty by default, which allows you to glide from a note to another. So here I will play this pattern. Okay, but if I want, okay, so you can see here the visual representation of this small synths. So you can hear kind of an envelope, but it's not. It's only using the sync telephone to change the filter cutoff and the feedback, so that you have more movement in the patch. Okay, then what about gliding to another note? Okay, so change the octave, and not that fast. Okay, that's cool. So here is, as I said, the note column. I will create another pattern. Go on the pattern example. Reset its length to 8 bits, and then write some notes. No, what about remove the pattern and duplicate this one. Example, and I was in light blue. Okay. Okay, so I have the same pattern here, but then I can have I can add to a note column a few column effects. So here I will just add 1. And then, as you can see, I have this new column, this new information in the column. So these are effects that allows you to change the behavior of the notes. So you can add some randomness, some vibrato, tremolo, and other things. So if I use, for example, the uppercase C and go with a value of 55. So as you can see, the notes are not always playing because C uppercase C is the chance effect. So here 88 is a percentage of chance for the note to play, so it's quite high. But what about using vibrato? Perhaps lower value. So vibrato is not working with a single number from 0 to 19, but with it divides the first digit and the second to define the vibrato frequency, the vibrato amplitude. So if I go to 35. Okay, then what about adding a CV column? So a CV column, unlike note column, is meant to be assigned to a specific synth. So here I have to set the synths I want to use. So I can have up to 99 synths, but I will keep to the synth 0 as I want to use this one. And the synth channel is a modulation here. So I can go from 1 to 8, and it will be represented here from 0 to 7. CV column can be have different modes. So you have CV, gate, and BPM. CV will allows you to create a complex envelope, while the gate mode will have only up and down value, and you have the BPM, which allows you to change the BPM of the track. So here, if I add a scope to output the first modulation, you can see the same shape here and here. And then you can use it for whatever you want in the patch. Okay, so I talked about note column and CV columns. So okay, and then you have okay. So what about the different gate mode? So I talked about so the lead here. The lead instrument is using the gate mode. So I have to stop the note manually to make the note stop. Okay, but if you go to the pattern, to the bass pattern, and see the bass instrument, you will see that it is using the trigger mode. So you do not have to stop the note. This won't have any change. The gate output will simply be triggers, as you can see here. Really simple triggers. Well, if I go to the lead, you can see that the gate is always on. Until it reaches another note or not stop. And then you have the drum mode, which will use the pitch here, not the octave, but the pitch to be splitted into the different channels. As you can see here, I use the velocity, not to change the velocity of the drum, but the timbre. Okay, so I talked about how the pattern can be edited, and now I go back to the timeline. So here I have the timeline. I can simply, as I showed you, I can take a pattern and play it by using play pattern. So it will play it solo. But you can also play the full track with play song. So it will start from 0 and then go to the end of the track. So the end of the track is defined by the last pattern in the timeline. And then it will loops. Okay, so I will put this instrument, enable this instrument, and show you the other playing mode. So I can select a pattern instance, and then press play, and then press play pattern. Which so the play pattern does not have the same behavior when you are in pattern mode, which will play the pattern solo. In timeline mode, it will play disable it again, just for the explanation. It will it will loops on the timeline on the zone of the selected pattern, instance pattern. So here, as you can see, it loops on this zone. Then I can select another pattern instance, and once the previous one is done, it jumps to the next one. So this can be used for live performance. So as I showed you here, I have another instrument line, but I'm not using the T-synth or T-drum. I want to have some randomly generated pitch. So I used T-clock, which is simply generated triggers, gates, synced to the track. So here I have a bit multiplied by 2 and bit multiplied by 3. I merge them to have to trigger a string from surge_xt, and then I use the sample hold to get a random pitch value. Then the pitch value is quantized to the track with tquant. I also merge it polyphonically to send it to the string. So what about creating an empty pattern, dark blue, put it here, and playing it? Because the idea is that the clock, the T clock and the T phase modules are only working when the track is playing. So here, if I have an empty pattern and I'm playing it, it's working. So here, I also use the T phase, which will change the filter cutoff and the string VCO exciter and stiffness. So I can remove the pattern and then play the track. So of course, this synth won't be displayed in the T state, as it is not connected to any of the tracker synths. Okay, so I talked about T-synths and T-drums, I guess. As you can see here on the modulation, so on the pattern drum, I have this CV column, which is connected to the synth 2, which is this one. So the drum module. and then it's connected to the channel to the modulation channel 0, which is the first one. And here, as you can see, it is mapped to this knob. So to do that, you can simply right-click on the module, go to the CV, the corresponding CV. You can change the output range. So you have some basic presets, but you can set it by yourself. See, also, and you can also map the value to a knob and then change the range of the mapping. So as you can see, if I play here, it's moving the input tilt angle from Elastica. Okay, so I think we saw all of the modules. So we have T-clock and T-phase, which are generating clock, sync clock and LFO. T-quant, which is quantizing output external pitch information, and then T-drum and T-synth, which are outputting, not creating any sound, but outputting pitch gate, velocity, and panning information to be used into your patch. So you can arrange your patterns the way you want. You have up to 32 lines, and you can go from left to right on the x-axis to have a quite long track. Okay, so I think that's it. Let's play the track one more time. So here the bass is way lower on the display, because the y-axis is showing you the pitch information. You can see the glide here. The x-axis will be the panning if ever you use the panning information, and the velocity will change the size of the small dots.